Okay, so more fun with chapter one on defining some of these things. We left off with cross-sectional studies, case control studies, cohort studies, right? So we're looking at observational studies versus designed experiments. A designed experiment when you think about it in a designed experiment, it's important to know that you're intentionally involving yourself. You're manipulating something and determining how that manipulation is affecting your results. So that's really the key difference between a designed experiment and observational studies. In an observational study, you just sit back and watch what happens, right? So if you wanted to think about sodas, for example, in my opinion, I think that in 30 years, we'll look at sodas kind of like the same way we looked at tobacco in the 60s and 70s. People just were convinced that there was nothing wrong with them and they were fine. And in some ways, they were kind of helpful and they kind of give you a pep in your step and that kind of thing. But then later it turned out that they're actually really terrible and they, give you a lot of medical problems. Personally, I think that's what's going to happen with soda. That right now we don't really think of it as that big of a thing. But I think in 30 years they'll probably figure out the sodas are probably really bad for you and lead to diabetes and all kinds of problems. Anyway, how do we convince people of that? How do we figure out if that's true, right? So in an observational study, we would just watch, right? We just look around. Let's pick 1,000 people and observe them. Let's see how often they consume soda. Let's see their habits. Let's keep track of their health records. And then wait 20 years and see if those people that drank a lot of soda end up having more medical problems, right? That would be an observational study. On the other hand, if it was an experiment, what we would do is we would take a random group of people, we would randomly assign them to two different groups. One group, we would say, you are never allowed to touch soda, ever, right? And we just watch them for 20, 30 years. And then another group, we would force them to drink a lot of soda, right? You have to have a 2-liter bottle of soda every single day for the next 20 years, right? And then we would watch their health. And we would compare the results of the group of people that never, ever, ever, ever touched the soda ever, and the group of people that were forced to guzzle down a 2-liter bottle of soda every single day for 20 years, and see if there's any problems, if there's any differences between the two, right? Obviously, there are ethical problems with doing something like that, and logistical problems, all kinds of problems, right? People don't want to necessarily volunteer for something like that. So there's problems with implementing an experiment in many cases. So we settle for second best, and observational studies are definitely second best, always. Experiments are always better than the results of an experiment are always better than the results of an observational study. Designed experiments lead to being able to establish causality, that one thing causes the other conclusively. That's the results of an experiment. We can scientifically prove that thing X causes thing Y, right? We can make that connection. That's through a designed experiment. An observational study cannot do that ever, right? Because say, for example, in the case of following a group of people and seeing what their habits are and deciding, oh, look, we've just kind of paid attention to these people, and the ones that chose to drink a lot of soda, it seems like maybe they have more medical problems. But that's not going to be a conclusive connection between the two, right? If you can imagine, the soda companies are just going to fight back and say, well, maybe it wasn't the soda. Maybe those people also eat a lot of potato chips. Maybe it's the potato chips that are doing it. How am I supposed to know that that's not the case, right? So we cannot establish a direct causality relationship between a explanatory variable and a response variable. We cannot do that with observational studies, but sometimes we have no choice. We gotta do what we can, and for various reasons, could be money, could be ethical reasons, we can't do experiments all the time. We just have to kind of observe what happens. Okay. Are there any questions between the differences between an observational study versus a designed experiment? No? No? There's a lot of ethical stuff that happens with designed experiments. During the late 1930s to early 1940s, there were a lot of medical experiments, actual experiments done on people by the Nazis in Germany. And they were good scientific experiments, so they produced good, valuable data, but they were done in very cruel and inhumane ways. The experiments would be maybe to explore what the brain does, for example. So they'd take a perfectly healthy person and operate on their brain and like remove a chunk of their brain and then close them back up and see what happens. Oh, look, now he can't speak. Oh, okay, so that's how that part of the brain controls speech. Really cruel experiments like that. And we did gain a lot of useful scientific knowledge, but at a very, very high cost, very, very cruel cost. And after the war, there was a lot of debate about whether we should use that data, whether we should accept it, and then the damage has been done, and there was nothing you could do after the fact. So some people said, we should at least honor their memories of all the people that were, sacrificed, and all the pain that people were inflicted, that was inflicted onto people, and at least use the data. But others think that, if we use the data, then we give license to other people in the future to do the same thing, because they know that, they'll judge me poorly at the moment, but whatever results I get, they'll eventually use them. So I don't know. I don't know what you guys think. Should we have used that information, that data, because the damage is done, so we might as well reap some reward out of it, all those people that suffered? Or should we reject all that information and data because it was obtained in such a terrible way, so that we don't incentivize people in the future from doing the same thing? So who knows? Something to think about. There's a lot of great stuff about that if you want to Google information about Nazi experiments, during, mostly in concentration camps and stuff during World War II. And that's a lot of very interesting information there. Anyway, so no questions between the difference between an observational study versus a designed experiment? No. Okay, so this is the gold standard, designed experiment, if you can do it, right? If there is no moral dilemmas, if money is not a problem, if you have access to whatever it is you're doing, the experimenting on. Sometimes just access is the problem. Like maybe you want to do an experiment on, I don't know, Martian rocks, and we have a very limited supply of them, so maybe you aren't able to do a full-on designed experiment. Or maybe the experiment involves being in Mars to really do the experiment. So sometimes you don't have access to the subject or the material that you want to do an experiment on. Sometimes it's just really expensive, right? Maybe you don't have the funds to do that kind of a thing. For example, when a car company wants to bring an automobile to production, one of the things they have to do is they have to subject some of their cars to accidents. So they have to give away a bunch of cars to government agencies so they can crash them, right? Hit them from the side, hit them from the front, hit them from the back. So it's pretty expensive for the company to get one of their vehicles to be certified. That's why a lot of cars are not roadworthy. They're not legal to drive on the streets. Not necessarily because they're not good vehicles. It's just that the company never decided to get them tested that way, right? Think of like really expensive hypercars that are, $3 million for the car. They might not be legal on the streets, not because they're not safe cars or anything, but because the company didn't feel like handing over 5 or 6 $3 million cars to the government so the government can crash them and certify that they are roadworthy, right? So the experiment is just way too expensive, and they chose not to do it. So design experiment, if you can do it, is the gold standard. And that's the only thing that will establish causality. One thing causes the other, period. That's the only thing that will do that. In many, 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 many things, we just settle for second best, which is an observational study. But at best, an observational study can establish a connection, a correlation, some sort of influence between one thing and another, but it could never establish that one thing causes the other. It could not establish causality, right? That's one of the big things in pop culture that people hear, that some sort of study made a connection between two things, and they jump to the conclusion that that must mean causality. One thing causes the other, and that's just not true. At best, it establishes a correlation, a relationship between the two things, that there's some similarities there, or that some sort of interaction is happening between the response variable and the explanatory variable, but we cannot establish causality. Okay, we're good? Questions at all about observational studies versus designed experiments? No? No? Okay, now within the world of observational studies, we have a couple of flavors here. We have cross-sectional studies, we have case control studies, and we have cohort studies. So cross-sectional studies are observational studies that collect information about individuals at a specific point in time or over a very short period of time. Good. I mean, this could be as simple as a survey. You just stand in a corner somewhere and hand out surveys, and you're gathering information from them. So that could be a cross-sectional study. Or maybe you obtain information in the form of, I don't know, maybe you weigh people. You go to a intersection with lots of people are walking by, and you kind of randomly pick some people and you weigh them, and that's how you're gathering your data. And asking them some questions, maybe about their eating habits or what they've eaten that day. Maybe you just want to get information about what kind of a breakfast the typical American has, or how much sleep they had. Maybe you stop people in the morning at a Starbucks and you ask them, how many hours of sleep did you have last night? And you might get 3 hours, 7 hours. I haven't slept. That kind of information. Cross-sectional. So you collect your data about the individuals at a very specific point in time, at a specific point in time, or over a very short period of time. A case control study, these studies are retrospective, meaning that they require individuals to look back in time or require the researcher to look at existing records. In case control studies, individuals who have certain characteristics are matched with those that do not. Okay, so I think as the definition implies, you look back at records. You figure out something about birth rates in 1970 or something. Maybe you're localizing it to a particular state that had some traumatic event. I don't know. Like, let's say, for example, we were looking at Louisiana during the Katrina hurricane. We wanted to see how that impacted birth rates, that kind of thing. Did people choose to have children, less children or more children that year? Was it impacted at all? Right? Okay. Cohort studies. A cohort study, first identifies a group of individuals to participate in the study, the cohort. The cohort is then observed over a long period of time. Over this time, characteristics about the individuals are recorded. Because the data is collected over time, cohort studies are prospective, right? So this is kind of like that soda study I said. Let's just watch 1,000 people for the next 20 years and keep track of their medical activity, right? So we, at the beginning, take a good detailed medical record of where they stand at that starting point. And then maybe once a year, we invite them to come in and keep track of how they're doing. And also get information about what their soda consumption has been like, right? It's an observational study, so we're not forcing anything. Maybe they choose to drink a lot of soda on their own, or maybe they choose to stop drinking soda on their own, right? We don't have any we don't influence the explanatory variable in any way in any of these observational studies. We just observe what they're doing and record. Good. Once we have all that data, then of course we try and see if there are correlations, connections between the explanatory variable, which in this case, in my little scenario, would be drinking of soda habits, and the response variable, which would be health. Maybe in particular, I might be looking at diabetes. Good, good, good. Or it might be weight. Maybe soda consumption and weight, obesity, or diabetes, who knows, right? There might be heart issues, all kinds of things. Maybe Parkinson's or dementia. Maybe I'm looking to see if people that drink a lot of soda, once they are older, are they more likely to develop Alzheimer's disease or something. Good. Any questions about those? Here's some examples. Let's determine whether each of the following studies depicts an observational study or an experiment. If the researcher concluded an observation, if the researchers conducted an observational study, determine the type of observational study. Okay, researchers wanted to assess the long-term psychological effects of children evacuated during World War II. They obtained a sample of 169 former evacuees and a control group of 43 people who were children during the war but were not evacuated. The subjects' mental state were evaluated using questionnaires. It was determined that psychological well-being of individuals was adversely affected by evacuations, right? So this is an observational study, right? We did not do an experiment. We did not separate people into two groups and then made some sort of decision about how to impact them, right? If we wanted to convert this into an experiment, we would say, back during World War II, we grabbed two groups of people, children in this case, randomly assigned them to two groups, and then we randomly chose one group to be evacuated and the other group to not be evacuated, right? So that would be an experiment, but this is not an experiment. We have no control. The researchers, looking at this, had no control over who got evacuated and who didn't get evacuated. Good. And this is a case control observational study. Right? Case control. Right? The studies are retrospective. We're looking back at records, back to World War II, and determining what happened. Good. Okay. Another example. Xylitol has proven effective in preventing dental cavities, dental cavities, when included in food or gum. A total of 75 Peruvian children were given milk with and without xylitol and were asked to evaluate the taste of each. Overall, the children preferred the milk flavored with xylitol. Okay, so this is an experiment. We're impacting what they do, right? We're intentionally giving some children this drug and some children we're not giving them this drug. There's no ethical issues here, hopefully. We're very confident that this drug will not have a negative effect on people, so we feel ethically secure that we're allowed to give it to people. And so this is an experiment. Looks like all we were really doing, though, is evaluating whether the children preferred the milk with xylitol or without xylitol, right? So I guess flavor is what we're really checking here. A good follow-up would be to come back and follow them some number of years later and see what their dental health was like, right? Assuming we continue with this treatment. So it's a designed experiment. Good. A total of 974 homeless women in Los Angeles area were surveyed to determine their level of satisfaction with the healthcare provided by the shelter clinics versus the healthcare provided by government clinics. The women reported greater quality satisfaction with the shelter and outreach clinics compared to the government clinics. Okay, so this is an observational study, right? We're not randomly assigning some women to go to one clinic and some women to go to another clinic. They're choosing for themselves which clinic they would like to go to and when they would like to go, and they are just reporting what their opinion is on the clinics. So it's definitely an observational study, and it's also a cross-sectional type of study, right? So it's an observational study that collects information about individuals at a specific point in time, right? We're just stopping them at that point in time and asking them what they think in that point in time. Good. Okay, another example. The Cancer Prevention Study 2 is funded and conducted by the American Cancer Society. Its goal is to examine the relationship among environmental and lifestyle factors on cancer cases by tracking approximately 1.2 million men and women. Study participants completed an initial study questionnaire in 1982, providing information on a range of lifestyle factors such as diet, alcohol, and tobacco use, occupation, mental history, and family cancer history. These data have been examined extensively in relation to cancer mortality. Vital statistics of study participants is updated biannually. Causes of death has been documented for over 98% of the deaths that have occurred. Mortality follow-up to the CPS2 participants is complete through 2002 and is expected to continue for many years. Okay, so they're just keeping track of these people, right? So this is a cohort study. It's over a long period of time. You grabbed a big group of people, you kept track of their medical data, and on a biannual basis, you go back and get more data, keep track of these people until they die, and then they gather cause of death information so that you can try and see if there's a connection between their lifestyle factors and cancer and cause of death. Any questions? Okay, more definitions. A census is a list of individuals in a population along with certain characteristics of each individual. Okay, a census is when you have information about a particular characteristic from every individual in your population. At the moment, we're going through the U.S. Census, right? So written into our Constitution, it is important that every 10 years the government counts how many people live in the country and where do they live, which state do they live in, right? So the government is charged with doing that every 10 years. It's built into our Constitution, and we're doing it this year, right? So that's a census. Don't confuse that with samples, right? A sample is a little subgroup of the population. Good. Okay. Simple random sampling. So our learning objective in this next section is just to learn about samples, right? To compare that, contrast that with taking a census. Okay, so random sampling is the process of using chance to select individuals from a population to be included in a sample. If convenience is used to obtain a sample, the results of the survey are meaningless, right? Convenience or members that self-select, right? So if you ask for volunteers, hey, who wants to be a volunteer in this sample, then it's kind of mathematically, statistically useless information. Good. Those members of the sample that come from the population must be randomly selected so that you have a good chance of having a sample that accurately reflects the population by statistical characteristics, right? So for example, if I wanted to get a sample of 100 students that represent the entire population of our college, right? Our college has nearly 20,000 students. So if I just wanted to get 100 students that do a pretty good job of reflecting the college, right? In terms of ages and race and who works full-time, who doesn't work full-time, children, live at home, don't live at home, long commutes, short commutes, they learn, they take online classes versus in person, right? All those characteristics of the population of the entire school, I want to be able to have a small sample that reflects that, so that if I study my little sample, right, it's really difficult to study the entire college, 20,000 students. If I wanted to learn how the students feel about something, right? Is there enough parking at our school? Is that a problem? How do I find that out, right? I could ask every single student at the college, but that's a lot of work. That's a lot of students. So instead, what we want to do is get a little sample that does a really good job of impersonating the entire college. It's a little microcosm of the entire college right there in that tiny little group of 100 people. And so that 100 people should do a good job of reflecting the number of men versus the number of women in the entire college, right? So if in the entire college we're 60% female, then my sample should be about 60% female, right? Approximately. If my entire college is 32% Asian, then my sample should also be about that, 32%, right? If my entire population, 20% of the entire population has children, then the same should be of my little sample, ideally, right? It should be like a little microcosm, so that when I ask questions to those people in my sample, those 100 people, and I get their perspective on things, there's a good chance, though not guaranteed, there's a good chance that those 100 people will do a good job of representing the entire school and how the entire school feels about certain things. Good? But that's why it's important for those 100 people in my sample to be selected at random from the population. Because if I just ask for volunteers, for example, then there's a very good chance that that my little sample won't really reflect the entire school, right? There might be, for example, a big chunk of students that are very shy at my school. The entire college, there's a couple thousand students that are really, really shy. So therefore, just by definition, they wouldn't volunteer to be in a sample. And so therefore, when I'm looking at my sample doesn't really reflect that group of people that are really shy, right? These people are really vocal and active, and they chose to be in that sample. So, you know, they're the loudmouths. They're the extroverts that are very vocal about how they feel, and that might not be truly reflective about how the entire college feels. No, that's one example. Two. Maybe if I ask for volunteers, it's more likely that people that have a lot of free time decide to volunteer. You know, they're not doing anything anyway, they're bored. Okay, sure, I'll participate, why not? People that are really busy, they have a full-time job, they have a full-time school load, they have 3 children at home, like they're just busy. The idea of having to participate, volunteering to participate in some survey thing, it doesn't appeal to them, so they kind of pass on it. And so you end up having a sample that doesn't really have those really, really busy people in that sample. So again, our sample fails to really, truly reflect the entire population. Good. So if you don't have a random sample, it's not really valid. Okay. A lot of it is convenience. For example, any time you ever have a like an internet survey of some kind, that is laziness from the people doing it. They just, we wanted to get information about the school, the student population. So I could just send out an email to 20,000 students and then just take the ones that responded, right? That's me being very lazy. Sure, I send out 20,000 emails, maybe I get 100 back. There's my sample. But again, that doesn't really mean that that sample is going to do a good job of reflecting the entire school population. I mean, there might be a group of people that are very bad with technology and they don't get emails. I mean, there's still people out there that have trouble with computers and logging in and figuring out what their email is. So if my method of trying to get a sample of students is just to send out an email and see who responds, then my sample isn't really going to include people that are technology deficit, right? Obviously. Also, maybe people have blockers in place and they see my email and they just think it's spam and like delete it. So again, my sample is gonna fail to include those kinds of people into my sample, and ultimately what you get is a sample that doesn't really reflect the population. And if your sample doesn't really reflect the population, then asking questions to that sample doesn't mean that you're going to get responses that are reflective of the entire population. Taking measurements of anybody in that population doesn't necessarily mean that you're getting useful information that's reflective of what the entire population is reflective of the entire population. Okay? So am I making it crystal clear that it's incredibly, incredibly, incredibly important that you do random sampling for your sample? If it's not random, it's junk. Useless junk. Right? That's why any kind of internet survey where people just volunteer to submit their results, it's all junk. Right? There's absolutely no statistical validity to that. Good. Add to it that, say for example, just surveys, how do you feel about thing X? And then, that's out there. Maybe you go to some website and it's keeping track of who said yes and who said no to a particular thing, if it's like a hot button thing. Keep in mind that a lot of people, when you throw something like that out there, you're going to get a lot of responses from people that are very vocal about that issue, very passionate about that issue in one way or the other. And so that, again, might not be reflective of how the entire population feels. That's just, it potentially, and might be a very small group of the population that's very vocal. Good. Questions? Like, for example, let me throw something out there that's not too controversial. In my neighborhood, there is a part of the neighborhood that has a fantastic view of the ocean. So they are very passionate about laws that impact their ocean view. So there's a lot of laws that involve like how tall trees can be, fences, how tall can your neighbor put up a fence, stuff like that. They're very, very involved when it comes to anything that impacts their view. So if a new law comes up that says, you know what, we should let people plant whatever tree they want whenever they want, no matter how tall it is, and maybe the city wants to put out a survey to see how people feel about heights of trees, I'm guessing you're going to get a very, very visceral response from those people that impacts them. So if you're just looking at the survey, you know, wow, we put this survey out and it was clear from the survey results, all the people that volunteered there to participate in the survey, I think you're going to get a lot of really strong negative, don't do it kind of things. So if you base yourself just on that, you think, wow, the entire city is very passionate about that particular law. They definitely don't want tall trees. But that's not really true. I think most of the city just doesn't really care one way or the other. Or maybe they actually do want tall trees, you know, away from the parts where you get really nice views of the ocean. Away from there, people might like nice, tall, beautiful fruit trees. So maybe they like that. So again, my point being that in this city, a very small group, let's just say 10% of the people, really, really, really care about having no tall trees. So in a volunteer survey, they would probably make themselves vocal and throw themselves into that survey and heavily push the conversation toward short trees only, no tall trees. So some outsider that's looking at just this survey might get the wrong impression about how the entire population feels. Good. So that's why random sampling is important, right? You can't let the people, the members of the population, self-select and choose to participate in it. You're not going to get a sample that truly reflects the population. Now, having said that, just like before, sometimes you have no choice. There might be, logistical reasons. There might be money reasons. There could be various reasons for why you can't have a truly random sample. So we might have to settle for second best, a almost random sampling, or just give up on the random sampling altogether, and then just recognize that this sample is not random, so therefore all the conclusions are not as scientifically secure as they could be if we had a random sampling. But like I said, sometimes you can't do better. You might have to settle for something, right? But the gold standard is random sampling. Any questions about anything that I just rambled on about? Good. Okay, within the world of random sampling, there is a few types of sampling techniques that we're going to look at. So the first thing we want to look at is simple random sampling. So a sample of size n from a population of size capital N is obtained through simple random sampling if every possible sample of size lowercase n has an equally likely chance of occurring. The sample is then called simple random sampling. Okay, this is the classic gold standard simple random sampling, and what I want you to visualize for this kind of sampling is that, imagine that I need to take 5 students from our class, simple random sampling. I want to create a method so that any 5 students have an equal chance of being selected into this sample. So the most classic way to do that and visualize it is everybody's name, right? I just write everybody's name on a little piece of paper, and then fold up each little piece of paper, throw it into a big hat, shake it up, and I'm just going to draw 5 names one at a time. I'm never going to repeat the same name, right? Once I pick out one name, reach in there, Tom, you're in my sample, right? I'm not going to put Tom's name back in the hat. So you reach in there, you grab one name, you reach in there, you grab another name, right? You do that 5 times, you got 5 people, there you go. Okay, so that technique will allow any 5 students in the population from being selected, right? So I'm not limiting any combination of students. Any combination is allowed, and they're all equally likely of occurring, right? Equally likely occurring from the stance of at the beginning, before you've done anything, then any combination is equally likely of occurring. Once you get through the middle of the process and you start singling out some of the people, then some combinations become less and less and less likely. In fact, some of them become impossible once you start making some choices. So when I say that they're all equally likely, that's before you start selecting any names and you're thinking about how you're going to do this process. all of them are equally likely of occurring. Good. Good. Okay, so names in a hat. That's the gold standard. That's simple random sampling. So here's just a quick example illustrating that. Suppose that a study consists of 5 students. So here is the entire population is 5 students: Bob, Patricia, Mike, Jan, and Maria. So 2 of the students must go to the board to demonstrate homework problems. List all possible samples of size 2. Okay, so it could be Bob and Patricia, Bob and Mike, Bob and Jan, Bob and Maria. Or it could be Patricia and Mike, Patricia and Jan, Patricia and Maria, and then Mike and Jan, Mike and Maria, or then Jan and Maria. So this is where order does not matter. So we are not including the case of Patricia then Bob, right? Those 2 are considered to be the same thing. So here's all possible outcomes. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible outcomes. Good. Okay. So if all 10 outcomes are equally likely of occurring, then we have ourselves a simple random sample. So obtain a frame that lists all the individuals in the population of interest, number of individuals in the frame. Steps for obtaining a simple random sample. Obtain a frame that lists all the individuals in the population of interest. Number the individuals in the frame from 1 through capital N. Use a random number table or graphing calculator or statistical software to randomly generate n numbers where n is the number of desired sample. Okay, so we can use technology to do that as well. So the classic visualization is to put names, right? Put Bob's name in a little piece of paper, fold it up, throw it in a hat. Put Patricia's name in a little piece of paper, fold it up, throw it in a hat. Right? So we can do that. We'd have 5 little pieces of paper, shake it up, randomly pick 2. That's one way to do it. The other way to do it that this is suggesting is to use technology. And as when we only have 5 people, what I suggested with the names is probably the easiest thing to do. But this method, the advantage of this method is that if we have a really big list, like hundreds or thousands of people, it would be a lot of work to write down everybody's name on a little piece of paper and then randomly pick the values, right? So instead, it would make a lot more sense to use technology. Jan, so this is a very popular way to do it. Maria. Okay, capital N represents the number of people in our population. Number of people in population. Whereas lowercase n is the number of people in our sample. Number of people in sample. Now I say people in this case because we're talking about people, but in many cases this might be car companies or soda brands or types of animals, right? So it could be anything, but in this case it happens to be people. So it could be number of objects in our population. Okay, so number of people in the population. In the population versus the sample. Lowercase n is the sample. Okay, so one thing we could do is note that n goes from 1 through 5 in this example, and so we can just have technology randomly give us some numbers, right? So randomly give me 2 numbers, and so you go to a computer program or something and say between 1 through 5, randomly give me 2 numbers. So it might give you the number 5 and the number 2, for example. And then you can come back and go, oh, that means it's Maria and Patricia. Remember, order doesn't matter. Good. So that's another way to do simple random sampling. And when n is really big, so instead of 5, maybe there's 5,000 names, we don't want to do a little piece of paper with 5,000 people. So a computer program does a better job of repeating the same process. Good. Questions, 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 questions. We will not be doing that in our class, and in practicality, we will not be really doing that at all. So just getting the visual of what simple random sampling is what's important for us, and so that visual of writing everybody's name, putting it in a hat, and drawing names is what you should think of when you're thinking of what is a simple random sample, right? All possible outcomes can happen, nothing's being restricted, and they're all equally likely of occurring. An example of a simple random sample: in the 112th Congress of the United States, had 435 members in the House of Representatives. Explain how to conduct a simple random sample of 5 members to attend a presidential luncheon, then obtain the sample. Okay, so put the members in alphabetical order, numbers from 1 to 435, and then randomly select 5, right? Use randomly select 5 numbers using a random number generator. Okay, so exactly what we've explained. So the random number generator will just spit out some numbers for you: 182, 207, 409, which so randomly assigned numbers, and then you go back and you match up the number to the name of the person, and that's how you can get your sample, right? But again, visualize all 435 names are written down on a little piece of paper, throw them in a hat, shake them up, pick 5 people. That's simple random sampling. There are a few other types of sampling methods we're going to look at. One of them is stratified sampling, the other one is systematic sampling, and the other one is cluster sampling. Okay. So a stratified sample is obtained by separating the population into non-overlapping groups called strata, and then obtaining a simple random sample from each stratum. The individuals within each stratum should be homogeneous or similar in some way. So, for example, what if I wanted to get a sample of students? I don't know. You're gonna go. Maybe there's a TV show, and they wanna, have 6 students represent El Camino College. So they want 6 students. So if we take all 20,000 El Camino College students, and we put all their names in a hat and shake it up, and we're just going to pick 6 students, then any 6 students are equally likely of being selected. And so there is that simple random sampling. On the other hand, maybe the school specifically wants to make sure that there are 3 males and 3 females. I don't know why. That's what they want. That's the representation that they want. They don't want to allow the possibility that some other gender makeup goes toward the group. They want to make sure it's 3 males, 3 females. So what they could do is separate the names of all the males in one camp, and from that group take 3, and then separate all the females, and then from that group take 3. Right? So there you can generate your sample of 6 students, guaranteeing that 3 of them are male and 3 of them are female. Good. So before you make your selection, the act of separating all the males and all the females, that's what the strata thing. Okay, strata, and then you take the sample. Another thing is maybe we want to create a panel of students to talk about their experience at El Camino. But maybe what we want to do is get 1 student from each degree that we offer, right? So we don't want to get a panel that is heavily represented in one field versus another. We want 1 business major, we want 1 math major, 1 engineering major, 1 biology major. We want 1 from each major that we offer. So we use computers to look at the students, and we break them down by strata, right, based on what their declared major is, And then once we have them broken down in strata, declared major, then we go in there and we randomly pick one student from each major, thereby guaranteeing that we'll end up getting a sample that has the particular makeup that we want to have. Good. Do we see how that's not simple random sampling? Because in simple random sampling, any makeup of students is equally likely of occurring. So if I just leave it up to simple random sampling, it's possible that my sample is made up of students that come from one field, that is overrepresented by students that have from one major, right? Like let's say maybe our school has a lot of business majors. That's just heavily impacted. The program is heavily impacted. There's a lot of business majors. So if we just randomly select 100 students, there's likely going to be a lot of business majors in that sample, which on the one hand is a good representation of the school. The sample might do a good job of accurately reflecting the makeup of the school, so it might be a good sample from that perspective. But if you intentionally want to make sure that each student from each major is chosen, then you might want to intervene and create a sample in this method. Are there any questions? No? Mm-hmm. Okay, so here's an example. In 2008, the United States Senate had 47 Republicans, 51 Democrats, and 2 independents. The president wants to have a luncheon with 4 Republicans, 4 Democrats, and 1 other. Obtain a stratified sample in order to select members who will attend the luncheon. Okay, so we don't want to just randomly select. Looks like the president is going to have lunch with 9 people, 4, 4, and 1. So if you just say any 9 people at random, then you are allowing the possibility that that sample of 9 people has a different makeup than this, right? A president is asking for 4 Republicans, 4 Democrats, 1 other. Good. So a simple random sampling would not guarantee that for you. Simple random sampling would say any outcome is equally likely of occurring. So there are many outcomes that would result that would not have this makeup, right? There's some outcomes where it'd be all Democrats or all Republicans. There would be some outcomes that have none of the independents. Probably a lot of outcomes that have none of the independents since there's only 2 of them. Right? In this scenario, who's the most influential group? Right? Some could argue that the independents are the most influential group, since there's only 2 of them, and one of them is going to get to go to this very important luncheon with the president. Right? So if you're one of these guys, you have 1 in 2 chance, 50% chance of being selected to go to this luncheon. Whereas if you were either a Republican or a Democrat, the odds of you being one of the 4 people from each camp to be selected are much smaller. Right? So in a way, you could say that these 4 people are more powerful, more influential. Right? In a way, but there's lots of ways to look at it. Anyway, so it's clear that this is stratified sampling. You're going to take the group of Republicans, the group of Democrats, the group of independents, you separate them by their political affiliation. So those are the strands. And then from each strand, you're going to randomly choose the number of people to make up your sample. Good. Okay, moving on. The next one is called a systematic sample. A systematic sample is obtained by selecting every kth individual from the population. The first individual selected at random is selected at random from numbers between 1 and k. Okay, so the classic example for this one is this right here. A quality control engineer wants to obtain a systematic sample of 25 bottles coming off a filling machine. To verify that the machine is working properly, design a sampling technique that can be used to obtain a sample of 25 bottles, right? So if you can imagine one of these bottling machines, I'm sure you've seen them somewhere, you can Google them. There's just this conveyor belt that's just like flowing out bottles really, really fast, right? Hundreds and hundreds of bottles are flying by. And so you want to randomly pick some of those bottles. And so if you choose to do it in this systematic method, what you do is step one, you're going to have to choose that first bottle. And then after you've chosen that first bottle, then you go, okay, well, after the first bottle selected, skip 30 and then pick another bottle, then skip another 30 and take another bottle, for example. Good. So, if possible, approximate the population size. So, in some cases, there will be an approximate sample size. Maybe it could be students in one classroom. There's about 30 of them. Or it could be people in a movie theater. I don't know. The room fills about 1,000, and it's kind of a sold-out movie. So let's say the people in a movie theater, about 1,000 people. Or okay, you could have this this scenario of having those bottles kind of fly by, and there's thousands and thousands. Like it never really ends. So you could have that. In a case like that, you don't really have a capital N. Okay. So determine the sample size desired, lowercase n. Compute n divided by lowercase n and round down to the nearest integer. Okay. So that gives you an idea approximately of how big the k should be, where k tells you how many to skip. Good. So now randomly select a number between 1 through k. Call this number p. So you're going to start at the pth one and then do k number of people after that. So let's for example, if in a movie theater, with approximately, let's say there's 1,000 people. And then when the movie ends, they all single file leave. There's only one exit. And so you can stand outside the room, right? So here's like the movie theater. Everyone's sitting here watching the movie, having a great time. You guys remember that? So long ago. Anyway, when the movie ends, people just kind of end up single filing out of their way. And so if you stand right here, you can watch them as they go, and then maybe you want to survey them. Maybe you want to ask something about them. Did they enjoy the movie? How often do they come to the movies? Did they buy popcorn? Are they likely to come back soon? All kinds of questions that you can ask them. And so you want to get a sample from them. So let's just follow these things here. So capital N in my little example here, capital N would be 1,000. You have to choose for yourself approximately how many people do you want in your survey. So n is the number of people in my sample. So let's say that I want, I don't know, let's say I want 40 people, approximately 40 people. Okay. So this is suggesting that in order to find the kth value, you should take capital N divided by lowercase n. So k then is equal to about 1,000 divided by about 40. Okay. So that gives you, what is that, 20, 25? Okay. I don't know why I'm having a brain. Yeah, 25. I don't know why I look weird for a second. Okay, anyway, so that's about 25 people. Okay, randomly select the number from 1 through k. So k is that. So now we'll let p be some number between 1 through 25. 1, 2, 3, 4, dot, 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 dot. 21, 22, 23, 24, 25. Okay, so there's all the numbers from 1 through 25, and we're going to let p be some value in there, right? Kind of randomly chosen. So maybe I let p be this guy, 4. Okay, so if we let p equal to 4, Now we have all the makings of what we need. So we're saying we're going to stop the fourth person and make them a member of my sample. Hey, let me stop you for a second. I'm going to ask you a bunch of questions, and if you answer them, you get a free ticket to come back to the movies or something. Okay, and then I'm going to count by K, which is 25, and then that's the next person I stop. So 4 plus 25 is going to lead me to 29. So I ask the fourth person, I'm going to ask the fourth person, and then I'm going to ask the 29th person to come out of the room to be a part of my sample. And then I'm going to ask the 4 plus twice 25, which is going to be equal to 54. Then the 54th person is also a member of my survey. Then it's the 4 plus triple 25, which will be the 79th person, right? And that's what this is describing. Dot, 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 dot. You just keep going that way. This will guarantee that, not guarantee, but this will give you approximately the number of people K. Approximately 25 people will be in your survey. Right, so the first person in my survey, the second one, the third one, the fourth one, and so on and so forth. Any questions about this? Okay, so this method has its benefits as well, sort of. In this case of trying to stop people coming out of a theater, this would be a good way to do it, because what other way would you do it? I guess you could ask everybody to give you people and go, hey, if I call your name, please don't leave the theater so that you can be part of a survey. That seems more messy, right? People don't want to. Like, you're going to have to take names of 1,000 people. Okay, I guess maybe if each individual seat is numbered, then I guess you can put all those numbers into a computer program to generate the 25 numbers you want. And then maybe at the end of the movie experience, you can kind of announce it. Hey, if you're seating in seats E25, seats B17, right, kind of call out the seat numbers that you want and ask people to stay behind so that they can participate in a survey. I guess that's somewhat doable. But a convenient way to do it would be to do this systematic sampling. If you're kind of on the outside and you're watching people walking out, and you kind of tackle them down. Any questions? No. Okay, next we're going to look at cluster sampling. A cluster sample is obtained by selecting all individuals within a randomly selected collection of groups, selected collection or group of individuals. Okay, so the population is either broken up into little groups, or maybe they are naturally clumped up in certain groups by certain characteristics. And then you're going to randomly pick one of those groups. Okay. So, for example, if I wanted to take a survey of students, right, if I wanted to do it simple random sampling, I would go to the computer programs at school, right, and get a list of all 20,000 students, and maybe I randomly select 20 of them. I have the computer randomly select 20 of them, and then I track them down. I call them, I email them, I go to their house, I go to their job, I track those people down and go, you were selected to be a member of this sample. Please let me get some information from you, right? That would be simple random sampling. On the other hand, if I wanted cluster sampling, what I could do is go to a particular classroom, right? I know right now it's COVID era, so we don't actually have classrooms, but ignoring this little scenario, for this little scenario, let's pretend everything's normal. So everyone is already in classrooms, so it would just be super easy for me to randomly pick a classroom, right? Randomly pick any room, any classroom in the entire campus, randomly walk into one of those classrooms and survey everybody in that classroom. So that would be cluster sampling. Good, good, good. So if the members of the population are already broken up into some sort of group, and then you randomly pick a group, and then that group is a member of your sample, then that would be an example of cluster sampling. Good. So a school estimator wants to obtain a sample of students in order to conduct a survey. She randomly selects 10 classes and administers the survey to all the students in those classrooms, right? So that's cluster sampling. Here's a nice little visual representation of each of them, right? So in simple random sampling, we have our population, and any group of people can be selected to be members of my sample, right? In stratified sampling, first you separate the population into strata that have some sort of homogeneous characteristics, something similar about them, like these are all the men, these are all the women, for example. Or it could be broken down by race, or it could be broken down by by degree, right? What their stated degree is, what degree they're trying to achieve. It could be broken down by highest level of math completed. It could be broken down by I don't know, zip codes where they live. It could be broken down by lots of different ways. So first you set up the little groups, and then from each individual group you grab people that through the process of simple random sampling within each strata, and then that's how you get your final sample of people, right? Thereby guaranteeing some sort of makeup. Like in this case, we are guaranteeing that we want 2 males, 2 females, right? Or maybe we want something different. Maybe we want 4 women and 2 men, right? So this process would guarantee that. Good. Yeah. Question.
Yeah. So in chapter 1, we have a population, a sample, and an individual.
Yes.
So here in chapter 1.4, we have the population, the sample, or the strata. Would the strata be? I see sample there. What part of the strata would fall from chapter 1, or would it be a whole different subject from the population, the sample, and the individual?
Okay, so let me see if I can answer that. So strata just means that you're separating your population. So this is still part of the population. You're just coming up with some way of separating them first before you pick your members. And then this over here is your actual sample. Good.
Got it.
So your population, see here, we didn't break them up in any kind of way. So we could just randomly pick anybody. So you have no real control over what happens with your sample. It could be lots of males, lots of females. It could be lots of business majors. It could be lots of people that live in zip code, 00204. You have no control. It could be anybody from in there. Simple random sampling allows all possible groups of that size. Any 3 people could have been chosen. No control. So if you want to have some control, like maybe this school happens to be situated in the middle of like 3 major zip codes. This is zip code 001, this is zip code 0002 and 0003. And maybe this is like the rich neighborhood, and this is the not so rich neighborhood, and this is like the middle, and your school happens to be like kind of like there. Like, here's my school. Okay, well, you want a sample of students, but maybe you want to make sure that they're all equally represented. So you want 3 students from each zip code. Okay, so you take your population of students, you break them up into groups of zip codes based on zip code, and then you take samples from each individual group, thereby guaranteeing that your sample has a particular makeup. Okay?
Yeah, thank you.
Okay. All right, so the strata is the thing you use to separate your population. It could be zip codes, it could be gender, it could be race, it could be your major, it could be height, it could be anything. Okay, any characteristic that can separate these people, and then you take your sample. Systematic is when you're able to organize all the people in a line, or maybe they are already like that. So, right? So that classic idea is people single file coming out of an airplane or coming out of a movie theater. They're already in like single file. So it just makes it convenient to stop some people and ask them to be part of the survey. Good. So there's a little process that you follow to figure out how to pick those people. So what you're saying here is, okay, I'm going to pick number 2, person number 2 that walks out of the movie theater, or person number 2 that walks out of the airplane, or person number 2 that walks out of the math building and starting at 8 a.m., right? You camp out, it's starting at 8 a.m., and you're going to, okay, as people walk out of this building, there's only one exit. I'm going to grab the second student, and then I'm going to count, and then the 5th student, and then I'm going to count, and then the 8th student, and then the 11th student, and there's my sample. Good. In a sort of a systematic sampling of people. Good. If you do it this way, you're really not guaranteeing that you're going to get that any group of people, any final sample is equally likely of occurring, because, for example, people leave a plane in a particular order. Right? There's some common characteristics of people. So, for example, in most planes that still have, classes, first class is in the front. Usually, they get that privilege of leaving the airplane first, right? So, if you're just standing out and watching people walk out of the airplane, and you want to get the first person, and then the 5th person, and then the 8th person, and then the 11th person. There's zero chance that you're going to get the first 4 people in your sample. That is not one of the possible surveys that you're going to get because you're doing systematic. So therefore, it's not true that all samples are possible, and it's not true that all samples are equally likely of occurring. The way they would be if I did it this way. If I took everybody's name in the airplane and I said, I'm going to randomly pick 3 people, it's possible that it could be that those 3 people are all in first class, and they were all in seat number 1, 2, 3. Maybe they were all related. It's possible. Simple random sampling allows that possibility. But with systematic sampling, it severely reduces that, right? Because it's more likely that first class passengers all kind of come out first. Not guaranteed. Maybe one of them, kind of sat behind and waited, and then maybe they're way back here. Or maybe they like waiting for the whole plane to empty and they can go out and be comfortable and not be rushed or whatever. So it's not guaranteed, but it's more likely that people in first class kind of walk out first. And it's also more likely that related people kind of walk out together. So it's more likely that these 3 people are somehow flying together, and that's why they are leaving together, or sort of clumped up. So anyway, not all samples are equally likely of occurring, and not all samples are even possible when you do systematic sampling. Good. So simple random sampling is the gold standard if you can do it. But logistically, there's several reasons for why it's not always the best thing to implement, but you do get the best results. On the other hand, sometimes you specifically want a particular makeup. Like I said, if you want some students to represent the school to be interviewed on TV, you maybe specifically want something. You want an equal number of men and women, or maybe you want particular majors, right? We want some business, we want some engineering, right? So you might want to interfere in your sample and make sure your sample has a particular makeup. Good. And then finally, cluster sampling. You take your whole population, and instead of creating strata, right, here strata is because they have some characteristic, like men versus women, right? But instead what you do is you take your whole population and you think about how they're broken up into natural groups or clusters, like classrooms, right? This is classroom 1, classroom 2, classroom 3. They're already broken up by certain groups. Or maybe houses, right? We're about to take the U.S. Census. So one of the things they do is they randomly pick houses and they go knock on them and they go, hey, can I ask how many people live here? And can I ask some information about who works and who doesn't work? And, that kind of thing. So
I did that last year.
What's that?
I did that last year.
Oh, you did that?
10 years ago, I actually did that.
Oh, okay. Well, they're about to do it again. So cluster sampling means that the entire population is already broken up into little groups, like a classroom or a house or something. Or if you're an airline, if you're American Airlines and you want to survey people, uh, people are already grouped up into flights. So maybe you randomly select one flight and then you go and you survey everybody on that plane. And so that's cluster sampling. Okay, any questions about the differences? Good, 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 good. There's a lot of controversy with the census in particular because originally, well, not originally, but the intention, some people feel that the intention has always been that they literally count people. You know, 1, 2, 3, 4, count them. How many are there? But that's hard to do, especially as our population has grown bigger and bigger and bigger and bigger, right? We're expecting that our census this year will probably be a little higher than 320 million people. So that's a lot of people to count. So instead, we have relied more and more and more on statistical theory to help us get a sense, get an idea of what that number is, rather than actually count people. And that's been a source of controversy because obviously with anything we do in math, there's always going to be some level of error, right? I mean, we could be wrong. We're going to literally count some of the people in a way that is consistent with statistical theory, and then we're going to use those results to make really, really, really good guesses about the entire population. But no matter how good that guess is, it's always going to be a guess. So there will always be some level of error, and some people aren't happy about that. So the controversy is, should we make an attempt to literally count people, 1, 2, 3, 4, 5, count them, or should we devote our resources to only counting some of them, but in a way that is consistent with statistical theory, so that we can use math and statistics to get a really good idea of how many people live in this country and where they live, which state they live in, right? So that's something to think about. Is it worth it? Some people are very unhappy because obviously, what if we make a mathematical mistake and then we could be wrong? But then again, when you're actually literally counting people, there's a lot of room for mistakes there too. So, I don't know, something to think about, right? When you're literally counting people, it's really hard to do that. Especially, there's a lot of groups of people that are really hard to count. Particularly the homeless, for example. People that work a lot, they're hardly ever home. And there's a lot of people that kind of live off the grid. They live pretty far away from everyone else, so it's kind of hard to find them. Some people work pretty hard to not be in the system, right? Not be on the grid. So it's kind of hard to know where they are and how many there are and all that, right? And there's a lot of people that don't trust when someone comes knocking at the door and asks questions about who lives there and whatnot. They're not going to answer the door. They're not going to answer your questions. They don't want to participate. They don't trust you. They don't know what this is about. And so it makes it really hard to literally count people. So who knows? The debate goes on. Good. Okay, other effective sampling methods. Okay, stratified and cluster samples are different. In a stratified sample, we divide the population into 2 or more homogeneous groups, right? Homogeneous means that they have some particular characteristic in common. So this is the males versus females, for example. Then we obtain a sample, a simple random sample from each group. In a cluster sample, we divide the population into groups, obtain a simple random sample of some groups, right? And survey all the individuals in the selected groups. So we randomly pick a group and then survey everybody in that group. Good. So again, with the airline, for example, if I'm on the board of on the board of American Airlines, and I want to find out about my customers. One thing I could do is maybe I want to survey. I want a survey that tells me information about my customers, but maybe I don't just want any random sample of anybody that has ever flown on my airline. I want to maybe focus on where the money is, right? I mean, my frequent flyers, those are the people that I care about the most. So maybe I want to separate my list of contact information, right? Because whenever you buy a ticket, you give them your email and stuff. So I have all that contact information, but maybe I want to separate it so that I have people that are frequent flyers, people that fly at least once a week. There's people that fly once a week, for months. So people that fly once a week, maybe that compare it to people that don't fly that often, but maybe spend a lot of money. So maybe they're the first class people that drop the big bucks on the big flights. One time I flew from LAX to I forgot where that. I think it was like Hong Kong maybe. Anyway, it wasn't my final destination, but it was one of the flights on kind of moving on to where I'm going. But anyway, the big leg of the flight was from LA to Hong Kong, and I think my ticket was like $1,200 or something like that for coach kind of ticket. And then shortly after, I got an email that invited me to upgrade to a first class ticket for a nominal fee upgrade, right? And I was like, oh, okay, a nominal fee upgrade. Should I consider that? My ticket was like $1,200. How much more could they possibly want to upgrade to first class? It was like $10,000. They emailed me if I wanted to spend an additional $10,000 to upgrade to first class on that flight.
Airlines are ridiculous.
Yeah. So I was like, really? No, thank you. But I mean, it occurred to me like somebody out there does that. Like somebody's spending 10 grand on a flight to be in first class. So anyway, the airline might really care about hearing from those people a lot more than they want to hear from someone like me that just buys whatever the cheapest ticket is. So in order to hear from their customers, they might divide up their population, right? The population being all previous passengers for whom they have contact information. And so they might want to divide them into little strands: first class people, business people, frequent flyer people, and then everyone else, coach people that don't fly that often. Okay, and then maybe they want to random sample people from each group, right? That's stratified sampling. On the other hand, cluster sampling, they might just go into their computer system and they randomly pick 3 flights anywhere in the world, right? At any moment, they have thousands of flights all over the world. So maybe they just randomly pick 3 flights that are, going to happen today. And then they go to those airplanes and, before they take off, okay, we're about to take off. Or maybe in midair, that's a good place to do it. You've got them trapped in midair. Midair, you go on the mic and go, okay, you've been all selected to be part of this survey. Please fill out these surveys, and I don't know, if you, as a reward, we'll give you whatever, free peanuts or something, an extra soda, something. But anyway, now you're getting information from everybody in one airplane rather than this other method of breaking people down and having some control. Okay. Any questions about the differences? No. Another caution about convenience sampling, right? If the members of the population self-select to be members of the sample, that's not good, right? A convenience sample is one in which the individuals in the sample are easily obtained, as in they volunteer. That's one way to do it. Or you just grab the first few convenient, low-hanging fruit kind of thing. I wanted to get a survey of people, so how about if I just survey the people that are here right now? You guys are here. Congratulations, you're part of my sample, right? That's not convenient. I'm sorry, that's very convenient. So that's not going to do a good job of actually representing the population, right? So any studies that use this type of sampling generally results are suspect. Results should be looked upon with extreme skepticism. Okay, multi-stage sampling, right? So we can kind of combine these things and come up with different more complicated ways of getting your sample, where you have a combination of different types. So in practice, most large-scale surveys obtain samples using a combination of techniques just presented. As an example of multi-stage sampling, consider the Nielsen media research, right? So Nielsen randomly selects households and monitors the television programs these households are watching through a people meter. Right? The meter is an electronic box placed on each TV within the household. The people meter measures what program is being watched and who is watching it. Okay, well that's kind of weird. So it's got like a camera maybe pointing at the couch, and it's like keeping track of how many people are watching and who is watching it. So I'm sure these people self-select to be part of this, right? Because you can't randomly. Well, I guess maybe you can ask them, and then maybe they choose to be participants in this. Nielsen selects the households with use of a two-stage sampling process. So stage one, using U.S. Census data, Nielsen divides the country into geographic areas, strata. The stratas are typically city blocks in urban areas and geographic regions in rural areas. About 6,000 strata are randomly selected. Okay, so they subdivide the whole country into little groups based on whether you live in an urban area, whether you live in a certain city blocks. Nielsen then sends representatives to the selected strata and lists the households within the strata. The households are then randomly selected through a simple random sample. Good. Nielsen sells the information obtained to television stations and companies. This was also used to help determine prices for commercials. Right? They need to figure out who's watching it, and then they use that information to be able to assess the value of a particular TV show. Right? If a TV show attracts a lot of people, then that TV station can command more money for their commercials. And not just how many people, but also they like to get information about the ages of the people watching it, and males versus females, so that commercials can be more targeted, right? Maybe it's a product that sells particularly well to a particular group, right? So like video games, for example, traditionally sell best to people in the age ranges of like 18 to 35, in that sort of age range. You might wonder, what about below 18? They play a lot of video games, true, but they don't have any money. So we want people that play a lot of video games and have the money to buy them. So that could be your target, right? And above 35, they finally get a life, so they don't play as many video games, hopefully. So maybe that's your target. So you're looking for a TV show that attracts a lot of people in that age range. And also, studies show it's mostly men that play video games and buy the video games. So you want males, 18 to 35. So you want a TV show that attracts people like that. I don't know. Maybe American Ninja Warrior might be a TV show that does really well with that age group. Good. Questions? Okay. In this last section, we want to talk a little bit about biases. So, some definitions. So, if the results of the sample are not representative of the population, then the sample has bias, right? So, if we do a good job of selecting our sample through a random process, and our sample does a really good job of representing the population in all aspects, like for example, if you think about our school, all 20,000 students, and I randomly pick 100, that 100, if that random sample of 100 was all male, that would obviously not be a good representation of the entire school, right? Or I randomly pick 100 students, and all 100 are business majors. That would not do a good job of representing the entire school, right? So we want a little microcosm, a little micro universe that represents the whole school. So it should do a good job of having about the same makeup of males to females, about the same makeup of students that have children versus that are parents, students that are parents versus non-parents. A pretty good job of representing a percentage of students that have a full-time job versus not a full-time job, of students that commute long distance, students that, just about everything, right? It should do a good job of representing the school. If it fails to do that, if there's some characteristic that is very, very different in our sample of students versus the entire school, then there's a bias that exists there, okay? So that bias could be there on purpose. Somebody intentionally created that bias, or it could be there accidentally. But whether it's there on purpose or accidentally, the fact that it's there, nonetheless, you have bias. So when you have bias, then your results aren't going to be as good, right? Your sample doesn't do a good job of representing the entire population, so the results aren't going to be very good. And when I say the results, I should make that clear, right? Our goal in statistics is to have, we have a giant population, and we want to know something about this population. We want to know if they're going to vote yes or no on a certain thing, right? It doesn't matter. Thing A. How do they feel about thing A? Yes or no on it? I don't know, right? And there's a lot of people here. There's 20,000 people, so it's hard to really know how everybody feels about this thing, yes or no. So what we do is we take a little sample that's more manageable, and we're going to take that sample, maybe that sample only has 100, right? So this is capital N, I should say that here. Capital N is 20,000, the number of members of my population. And in my sample, we use lowercase n, maybe my sample only has 100. Right, and now it's a lot more manageable to ask about thing A here. Yes or no? What do you guys think? Thing A, yes or no? Okay, so what I'm going to do is I'm going to take information from here. Okay, so from here, maybe I get that 58 say yes, and 40 say no. And that means that 2, they have no idea. I don't know what I'm talking about. What thing? There's a thing A? I've never heard of it. Okay. So this is the results we get. There's no controversy here. This is exactly the results, right? No doubts at all. This is what I got. But the point is that we want to use this information from my sample to make a good guess about these people, right? The 20,000. Based on the 20,000, it looks like, okay, maybe about 58% of these people are going to say yes, maybe. Or can I at least say more than half are going to say yes? Maybe, right? So I want to do that, but it's definitely going to be a guess, but I want that guess to be as good as it can be, as accurate as it can be. And that's the most important part of statistics. That's what we're going to be doing. Making guesses about our population based on information from our sample. But in order for this guess to be good, the first thing we have to make sure is that it doesn't have any bias. We want to make sure that this sample does a really, really good job of representing this population. If it doesn't do that, if it's missing a group of people, or if it's overrepresenting a group of people, then when we get these results, they may not do a good job of accurately representing these people, right? It may not give you a good guess. Does that make sense? So if I got my sample by, say, back to the students, I got my 100 student sample by going on campus and randomly picking 100 students that are walking around. Okay, but that's not going to capture the students that take classes online. They're not walking around there, right? So that's not going to give you a good sample. So when I get information about things, that's not necessarily going to give you a good guess about how the entire school feels, because your sample didn't have any students that only learn online. Good. Or on the other hand, again, I go to school and I randomly pick people, but I do it in the morning. Then my sample is not going to include people that only take classes at night, the night learners. And night learners are probably more likely to have a full-time job. And that's why they're taking classes at night. So if my sample only has people that take classes in the morning and in the daytime, then again, the results from that sample are going to do a poor job of generating guesses for what the entire population feels. Good. Any questions? No? Okay, so we're going to look at or subcategorize biases into three general things. There's sampling bias, non-response bias, and response bias. Okay, sampling bias means that the technique used to obtain the individuals to be in the sample tends to favor one part of the population over another. Right, so this is, like I was saying, I just go to campus at 8 in the morning and I sample 100 students that are walking around. Okay, well, I'm not taking into consideration students that take night classes. So my sample isn't going to be reflective of the entire school. I'm not taking into consideration students that only take classes online. So my sample is not going to include those people. Got it? So the way in which I selected members of my sample is intentionally favoring one group of people or excluding a group of people. Good. Maybe in order to participate in my sample, what can I do? Maybe I decide to put flyers on the windshields of people. That could be one thing I do. People are busy. They're walking around. They don't want to let me stop them and talk to them. They're on their way to class. So maybe what I do is I go to the parking lot and I put a little sample thing on the windshield of cars. And even if I keep track of them, maybe I keep track of their license plate and I go to the school computer and I figure out license plates and contact info, and then I email them and go, hey, I left the survey on your windshield. Can you please participate or whatever? Even if you keep track of them like that, you're creating a bias, right? Because you're intentionally only including people in your sample that drove and parked a car to school. What about all the people that walked on campus? All the people that live on or near campus aren't going to be representative in your sample. All the people that took public transportation are not going to be in your sample. Good. So some sort of bias is there. Your sample intentionally favors one group of students over another. Right? Or maybe in order to be a member of my sample, I ask everybody to come to the theater. Come to the theater at 8 p.m. on a Monday, and we're gonna get everybody together, and we're gonna ask people questions and measure things, and you're gonna be part of our sample. Please come join us. Well, again, you're creating a bias, because for some people it might be really difficult to go to campus at 8 o'clock at night, and for some people it's really easy. If you live on campus or near campus, then it's not that big of a thing to walk on campus again and go to this big meeting. But if you live really far away, if you have to commute, traffic, work, like all kinds of other things could limit your participation in that and thereby favoring one group of people over another. Good. There's a really famous example. I think it's Dewey, I think was his name. In the 1952? Is that 1952? No, that couldn't have been 52. 48. I think it was 1948. A presidential campaign between Dewey and Truman. Right, you can look that up. They did a really extensive survey to try and determine who was going to win the presidency. And their methods led them to believe that Dewey was going to win. But, of course, Truman won. And they were so certain that Dewey was going to win that newspapers ran with headlines that, breaking news: Dewey won the presidency before the final vote was in. So anyway, there was just a lot of biases in their technique. I think what happened with them is that they selected people to be a member of their sample by going through DMV records. So they went to the DMV, they got addresses of people, and then they mailed them a little survey. Who do you think is going to win? Who are you going to vote for? And they did it that way. And so there was a lot of biases, especially in 1948. In order to have a car, in order to have a driver's license, you kind of had to be a little bit more well off, right? Cars were very, very expensive, relatively speaking. A lot of people couldn't afford a car. They couldn't afford to have a driver's license. So there was a bias there. The process by which they chose people in their sample favored people that were a little bit more well off financially, and it didn't include a whole lot of other people. So they got it wrong. Their sample did not do a good job of guessing what the entire population was thinking. Good. Undercoverage results in sampling bias. Undercoverage occurs when the proportion of one segment of the population is lower in the sample than it is in the population. Right? So if your sample has a very small percentage of business majors, and then you look around the population like, wait a minute, the most common major here is business. How come our sample doesn't have that many business majors? That would be undercoverage, right? Or, say Mexican. Maybe your campus has a lot of students that are Mexican, and then you take a sample, and then it has a very small percentage, a proportion of Mexican students in your sample, then that would be undercoverage. Right? So a bias exists because your sample is not doing a good job of representing the entire population. Non-response bias exists when individuals selected to be in the sample who do not respond to the survey have different opinions from those who do. So if we do a good job of selecting simple random sampling, I selected 100 students to be in my survey. Right? But just because I selected them doesn't mean that they want to be in it, right? Like you get an email that says, congratulations, you have been selected to be part of this panel of students. You might not want to participate. So maybe you ignore all the emails and you don't answer the call, or maybe you say you do, but then when it comes to actually filling out the survey and turning it in, you don't, that kind of thing. So you just are non-responsive, even though you've been selected. They did a good job. The people conducting the survey did a good job of selecting you through simple random sample processes, but you might not respond. And it might be that people who don't respond tend to have an opinion that is a little bit different than everyone else that does, and so therefore a bias again begins to be created. Good. For example, some people just don't choose to be so active, and they happen to have some sort of characteristic. Nothing good comes to mind, but at any rate, I think that that's probably a pretty self-evident one. Okay. Response bias exists when the answers on a survey do not reflect the true feelings of the respondent, right? So, for example, there's an interviewer error, right? So an interviewer is interacting with somebody that's a member of their sample. They're asking them questions, and maybe there's an error that happens there in communication, right? In the dialogue. There's a misunderstanding of some kind, and so therefore the response recorded doesn't truly reflect the feelings of the respondent. Good. Misrepresented answers. So again, maybe a mistake in which in the way in which you express your feelings. A lot of sometimes it's like you don't quite understand the options. You're reading and you're like, okay, choose one of these four options, and you don't quite understand it. They're worded kind of weird. You're like, wait a minute. I don't understand which of these four options truly reflects my feelings. So it could be a misrepresentation there. The wording on questions, the actual phrase used, has an impact. We have found that the actual language used when you ask a question impacts how people respond to it. So, for example, if you intentionally phrase it in a way that favors something, like if I said, do you favor punishing polluters that hurt our environment, or do you prefer to let them get away with it? If I say it like that, it automatically is putting an emphasis on, yeah, we should punish them, right? It would be difficult for someone to disagree with me to say, yep, let them get away with it. Right? Just the phrasing that I've used implies that I want a certain response from people, and I'm likely going to get that response more often than not. Good. The order of questions is also important. We know that it's a long list of questions. So if you ask them about the environment, and then you ask them about laws, and then you ask them about fines, in the order in which you ask things might make a big difference. So if you ask a question about tree heights in the neighborhood, right? Going back to that question, should we allow anybody to plant any tree of any height, and everyone should have the freedom to do that? Yes or no? Okay. Some people say yes. Some people say no. Another question could be, when a person violates a law, should they be fined? Should the city be allowed to fine you up to $10,000 for breaking one of the city ordinances? Now you're connecting money to it, right? So if that question comes up first, now you're thinking about money, violating city ordinances and being fined a lot of money. And now I ask you about this tree thing. Now you might think twice, like, maybe we shouldn't be, maybe we should, I don't know. It might impact your results. So in one way or another. So the order in which questions are asked might make a difference, right? So these are different ways in which a response bias might occur. Data entry error is an example. So although not technically a result of response bias, data entry error will lead to results that are not representative of the population. Once data are collected, the results may need to be entered into a computer, which could result in input errors, right? So the way in which you transform the data onto a computer. One very famous example that we should consider, since we have a presidential election coming around, is that sometimes there is misunderstanding as to what the process is, what the procedures are for submitting your ballot. So like there's some that have these little punch things. You like punch a little hole where you want, but if you turn the page, the hole you just created causes problems, right? So you're on page 1 and you punch a hole, and you're feeling pretty good about it. I punch there, I punch there, I punch there, I feel good. And now you turn the page, but now the holes you just created make things look a little weird. So now there could be some confusion that's caused. So that's one example of a problem that could occur. And then people don't follow the procedures. So for example, in a particular voting ballot thing, might require you to sign the bottom of each page. Page 1, I vote for this person, this person, this person, sign at the bottom. Next page, I vote for this person, this person, this person, sign at the bottom. Next page. And there might be 5 pages. And when you're done, you got to close the book, sign the front of the book, put it in an envelope, close the envelope, sign the outside of the envelope, and then put your full address, right? That could be the process. So what do we do if someone doesn't really follow every step? Like maybe somebody didn't sign the outside of the envelope, but they signed every page on the inside. What should we do? Should we count that ballot? Or should we go, no, didn't follow the rules, let's throw it in the trash, right? Or maybe they signed everything, but they forgot to put their address in the front, right? Or maybe they put something down, they squiggled something, but you can't make heads or tails out of it. It just looks like a weird rambling, it says put your address here, and all you see is kind of like that. Los Angeles County, like, I don't know, is that even an address? I can't tell. So what do? Do you throw that ballot out, or do you count it, right? And then you're supposed to sign each and every single page, but what if you skip one page? Do you not count that particular page because you didn't sign at the bottom? Or do you throw the whole thing out in the trash because the whole thing is invalid? Right, so there's a lot of questions, to be, for people to think through as you create your ballots, and a lot of opportunity for biases to exist, right? Where your sample no longer does a good job of representing the population. Good. So non-sampling errors are errors that result from sampling biases, non-response biases, response biases, or data entries, or data entry errors. Such errors could also be present in a complete census of the population. Right? So a complete census is when you ask a survey of every member of our population. Good. And versus a survey is when you pick a group of people and then you ask them, the members of that sample, questions or get data from them. Good. Sampling error is an error that results from using a sample to estimate the population, estimate information about a population. This type of error occurs because a sample gives incomplete information about a population. Good. So the sample doesn't do a good job of accurately representing the whole population. Good.